Okay, we are doing about the methods of preparation of alkenes. This is one method which is called by call-based electrolytic method. In the methods of preparation of alkene also we have done this method, electrolytic method. So to prepare alkene you can apply this call-based electrolytic method. So what is this method? When sodium salt of succinic acid. This is one example of carboxylic acid. When sodium salt of succinic acid are electrolyzed, then alkenes are produced. Alkenes are produced at the anode. So when sodium salt of succinic acid are electrolyzed, then alkenes are produced at the anode. First time I will tell you what is the formula of succinic acid. Succinic acid is one example of carboxylic acid. Its formula is like this. It contains 2 COOH group. This is the formula of succinic acid. As you know, this is one of the acid, and acid can release the H plus ion. When it reacts with sodium metal, then the H plus ion will release from the acid and the sodium ion will join and it produces salt which is called sodium salt of succinic acid. When this sodium salt of succinic acid is electrolyzed, then at the anode you will get the alkene as the product. So how to get this thing? So this is your sodium salt of succinic acid. Sodium salt of succinic acid. When you dissolve in water, after dissolving in water, it produces 2 ions. One is CH2COO minus ion, and 2 sodium ion will release like this because it is a salt. When salt is dissolved in water, always it produces cation and anion. So first time you have to dissolve sodium salt of succinic acid in water, then it produces some cations and anions which is called electrolytic solution. After taking the electrolytic solution, when you apply electricity, after passing electricity, at cathode, the positive ion will move as you have got in alkene. Sodium ion will gain electron. It produces sodium metal. Sodium metal will deposit at the cathode. Because cathode is negative, that's why positive ion always move towards the negative rod. And at anode, the negative ion will move. Your negative ion is CH2CO minus. It will lose 2 electron, and by release of electron, it produces a neutral compound like this. Negative charge will be neutralized, and this compound is unstable. Due to unstable character, it will break and it will form ethene, and this CO2 will release to produce carbon dioxide molecule. So ethene you will get as the product at anode. You know, in electrolysis, first time you have to take one electrolytic solution. After taking the electrolytic solution, you have to pass electricity through the solution. After passing electricity, at cathode the cations will move by gaining of electron, and at anode the negative ion will move by release of electron. You know, gain of electron is called reduction, release of electron is called oxidation. Some oxidation reaction taking place inside the solution. At cathode reduction takes place, and at anode oxidation takes place due to loss of electron. And like this way, at cathode you will get sodium metal as the product, and at anode you will get ethene as the product. So by applying this electrolysis method, by applying this electrolytic method, you can prepare ethene as the product. So this is one of the method of preparation which is called Kolbe electrolysis method. In exam you may get the question like this: how to prepare ethene by applying Kolbe's electrolytic method. Then you have to write this method like this way. Now, so these are the methods of preparation of alkenes. I have given 5 methods. Any one method may come in your exam. So you have to learn the reactions. Now we will do about the chemical properties of alkenes. I mean the chemical reactions of alkenes. Chemical properties of alkenes. I mean what type of reactions shown by alkene. As you know, alkene contain carbon-carbon double bond, and due to presence of carbon-carbon double bond, alkene shows maximum addition reaction. You know, in addition reaction, unsaturated compounds are converted to saturated compound. I mean double bond will be converted to single bond, and that type of reaction shown by your alkene due to presence of double bond. And since double bond is one of the functional group, as you know, functional groups are the most reactive part of the compound. So due to presence of functional group, alkenes are reactive in nature. So I will show you some addition reactions of alkenes. Number 1, addition of hydrogen. With alkene you can add hydrogen. For example, this is one of the alkene, ethene. When you add hydrogen with ethene, in presence of one catalyst nickel, temperature required 573 Kelvin, then both the carbon will take 1 hydrogen and the double bond will be converted to single bond. I mean this CH2, by adding hydrogen it will convert it to CH3, and this carbon also add with hydrogen to become CH3, and the double bond will be converted to single bond. And this type of reactions are called addition reaction, and you will get the product ethane. I mean ethene is converted to ethane by adding hydrogen. Similarly, if you take propene, this is propene. When you add hydrogen in presence of nickel catalyst, same temperature required, then both the double bonded carbon will added with 1 hydrogen, and the propene will convert it to propane like this. I mean one hydrogen is added with this double bonded carbon, another hydrogen is added with this double bonded carbon, and the double bond is converted to single bond. And this type of reactions are called addition reaction. In addition reaction you don't get any side product. Number 2, addition of halogen. I mean fluorine, chlorine, bromine, iodine, these are called halogens. Addition of halogen, and this reaction is also called halogenation reaction. This is one of the Zenel formula of alkene. When the alkene is added with halogen X2 like Cl2, Br2 like that, in presence of one catalyst carbon tetrachloride CCl4, this catalyst is required. Then one halogen will be joined with this carbon, another halogen will be joined with this carbon, and the double bond is converted to single bond. Addition always takes place with the double bonded carbon. Then the product you will get like this: one halogen will join with this carbon, another halogen joined with this carbon, and the double bond is converted to single bond. I mean you will get one dihaloalkane, because 2 halogen present, that's why it is said to be dihaloalkane. And as you have got, there are 2 types of dihaloalkane, vicinal and geminal. This is one example of vicinal dihaloalkane, because adjacent 2 carbon contain 2 halogen. For example, this is your alkene, ethene. When ethene is added with bromine halogen, in presence of carbon tetrachloride, then both the double bonded carbon will join with 1,1 bromine like this, and the double bond is converted to single bond. I mean, you will get the product 1,2-dibromoethane. This is carbon-carbon single bond, that's why it converts to alkane. That's why it is called ethane, 1,2-dibromoethane. Similarly, if you take propene, when you add halogen in presence of carbon tetrachloride catalyst, then with the double bonded carbon 1,1 halogen will join, and you will get the product like this. Here one halogen join, here one halogen join, and the double bond is converted to single bond. Naming 1, 2, 3, 1,2-dibromopropane you will get as the product. These are the example of fissional dihaloalkane. So this type of reactions are called addition reaction. In addition reaction, always the double bond is converted to single bond, and you don't get any side product in addition reaction.